Welcome to the deep dive. Ever stop to think how almost all the plastic stuff around you actually gets its shape?
Mm-hmm.
Today, we're diving into injection molding. It's the process behind, well, so much of it, based on the sources you sent over.
Yeah, fascinating stuff.
Our goal is pretty simple: give you a clear, quick, and maybe even surprising look at this really key manufacturing method.
Hopefully you'll see those everyday plastic items a bit differently afterward.
Exactly. Ready? Okay, let's unpack this. So, what is injection molding at its core?
It's fundamental, really.
Yeah.
At heart, injection molding is about forcing molten material, mostly plastics, thermoplastics and thermosets, into a specific shape using a mold.
Okay, molten plastic into a mold.
Right. The basic idea is you heat up plastic pellets till they're liquid, then you inject or kind of squirt that melt into a mold cavity under really high pressure.
High pressure, right.
Then it cools down, solidifies, and pop out comes your finished part.
Simple concept, but I bet the execution is complex.
Oh, absolutely. And it's actually got pretty old roots, patented way back in 1872, initially used for things like butters and combs.
Wow, 1872, so not a new idea then.
Not at all. But what makes it so powerful today is that mold. It's durable, reusable, so you can churn out huge numbers of identical parts.
Mm.
Very consistent.
Right, consistency and volume. And it's not a niche thing, is it? You mentioned it's
It's
dominant.
hugely dominant. It accounts for, well, sources say almost half of all plastics processing methods.
Half. That's massive. So why is it so popular?
Well, it really shines when you need to mass produce identical parts,
Ah.
especially if they have like complex shapes or intricate details.
So complexity isn't a barrier.
Not at all. Think about, I don't know, Lego bricks or intricate parts inside your phone.
Hmm.
Perfect for that.
Okay, and cost-wise, I imagine the molds aren't cheap.
That's the trade-off. The upfront cost for the mold can be high, yeah? But once you're making thousands or millions, the cost per part becomes incredibly low.
So economy of scale.
Exactly. It's a bit like die casting, but for plastics instead of metals. And this capability, it really pushes, polymer science forward and shapes how products are designed everywhere.
Okay, so let's walk through the actual process. It's a cycle, right?
Yeah, precise, repeatable cycle, it generally goes. Clamping, injection, dwelling sometimes called packing or holding, then cooling, mold opening, and finally ejection.
Clamping, injection, dwelling, cooling, opening, ejection. Got it. How long does one cycle take?
It varies a lot.
Mm.
Could be as quick as, say, 2 seconds for simple small parts, or stretch out to 2 minutes, or even more for large, complex ones.
And the main equipment.
You've got the injection molding machine itself that has the part that injects the plastic and the part that clamps the mold shut, and then you have the mold tool, which is custom made for the specific part.
Okay, let's break down those steps. First, clamping. What's involved there?
Right, so clamping is basically closing the two halves of the mold tightly together.
And it needs a lot of force, I gather.
Oh, immense force. We measure it in tonnage. It has to resist the pressure of the injected plastic. If the force isn't enough, you get leakage called flash.
Flash, okay, like excess plastic squeezing out.
Exactly. And there are different ways to clamp hydraulic systems, mechanical toggle clamps, electric, sometimes hybrids.
Okay, clamp tight. Then comes injection.
Yep, injection or filling. Plastic pellets, usually fed from a hopper, go into a heated barrel. Inside, there's a screw that rotates.
Uh-huh.
That screw action, plus heaters around the barrel, melts the plastic. Then the screw moves forward, like a plunger,
Okay.
forcing a specific amount of molten plastic, they call this the shot, out through a nozzle, into the mold's runner system, through the gates, and finally into the actual part cavity.
And under that high pressure you mentioned.
Extremely high pressure.
Right.
Could be up to like 29,000 psi.
Yeah.
Think about that. It forces the plastic into every tiny crevice.
Mhm.
Crucially, the mold needs tiny vents to let trapped air escape as the plastic rushes in.
Right, otherwise you'd get air bubbles. Okay, so the mold is filled. Then what was next? Dwelling.
Dwelling or packing or holding, yeah. So even after the cavity is initially full, pressure is usually maintained for a short period
Why is that?
because as the plastic starts to cool, it shrinks. This holding pressure pushes a bit more material in to compensate for that shrinkage. It helps ensure the part is fully formed and avoids defects like sink marks, little depressions on the surface.
I've seen those on some plastic things, so dwelling prevents that.
Helps prevent it, yes. This continues until the gate, the small opening where plastic enters a cavity, freezes solid.
Freezes solid. Okay, seals it off.
Right. Then we move properly into the cooling stage. The plastic keeps losing heat to the relatively cooler mold walls.
And molds often have cooling built in.
Oh yeah, very often. They'll have channels machined into them where coolant, like water, circulates to speed things up and control the temperature precisely. This cooling stage is usually the longest part of the whole cycle.
Makes sense. Gotta let it harden properly.
Exactly. And most of the part shrinkage happens during cooling, typically somewhere between, say, 0.4% and 2%. While this is happening, the screw in the injection unit is usually already retracting and melting plastic for the next shot. Getting ready.
Efficient. Okay, it's cool, it's solid, time to get it out.
That's right. Next is mold opening. The clamping unit pulls the two halves of the mold apart.
Simple enough.
Usually, for more complex parts with, like, undercuts or threads, there might be extra movements within the mold itself before or during opening. Then comes ejection.
How does it eject? Just fall out?
Not usually. There are ejector pins, or sometimes sleeves or blades, built into one half of the mold. They push forward and physically nudge the finished part out of the cavity.
Ah, those little circular marks you sometimes see on the bottom of plastic parts.
Often, yes. Those can be witness marks from the ejector pins. Designing where those pins push is critical so they don't damage the part.
I bet. Okay, part's out. What then?
Well, you might need to remove the sprue and runner system, those channels the plastic flowed through, unless it's a hot runner mold where that plastic stays molten.
Yeah.
Then, quality control checks. And often, the runner scrap and any rejected parts can be ground up and potentially reused. Regrind, they call it.
Reduces waste. Good. It really strikes me how linked all these stages are. You tweak one thing.
And it affects everything else. Exactly. The timing, the pressure, the temperature, it all needs incredibly precise control.
It's amazing to think about those huge pressures you mentioned.
Yeah, forcing hot liquid plastic into these intricate, tiny spaces.
And the speed, some stages lasting just seconds.
And the complexity hidden inside the mold itself. All those channels, cooling lines, ejector mechanisms, even the simplest looking plastic cup or chair has gone through this quite sophisticated dance.
Absolutely. So, to wrap it up quickly, injection molding is this incredibly efficient, high-volume process. It's how raw plastic gets turned into, well, a huge number of the shaped parts we use every single day.
Couldn't have said it better.
So here's a thought for you listening. The next time you pick up any plastic item, your phone case, a container, whatever, just pause for a second. Try and picture the two halves of the mold it came from.
Yeah, can you visualize that cycle? The injection, the cooling.
What design features needed special consideration in the mold, do you think? It's kind of fascinating. And, we've really just scratched the surface. There's a whole world of different plastic materials, complex mold designs, advanced techniques.
So definitely, multi-material molding, gas assist, micro-molding, lots more to explore.
So if you're curious about any specific part of that, just let us know.